Welcome to Southern Home Building, Blueprint for Energy, the last in our 5-part series on constructing energy-efficient homes. I'm Bruce Dueck, Chief of the Energy Conservation Division of the Jacksonville Electric Authority in Jacksonville, Florida. The JEA has designed this series to provide you with information you will need to plan, build, and equip your home with these energy-saving features that will give you the greatest return on your investment. The information presented in this series applies to the area shown in green on this map. This is the hot, humid climate region defined by the American Society of Heating, Refrigerating, and Air Conditioning Engineers, and in the United States consists mainly of the Gulf Coast regions. In this program, we will be dealing with heating, cooling, and distribution systems. Before we begin with one of the most prevalent problems in choosing heating and cooling equipment, proper equipment sizing, you will need to know what a Manual J calculation is. Manual J is the name of the highly regarded heat loss, heat gain calculation developed by the Air Conditioning Contractors of America. The Manual J calculation is generally accepted as the industry standard for calculating the correct size of residential heating and cooling equipment. Now that you know what a Manual J calculation is, let's find out more about it in our program.
Correct sizing of the air conditioning and heating equipment is one of the most important aspects of energy efficiency. George Spall is an award-winning builder of energy-efficient homes.
When we first started building this home, we received bids for the air conditioning work with estimates as high as 5 tons of air conditioning. After doing a precise Manual J calculation for the house, we found that we only needed 3 tons. This amounts to a savings of well over $1,000. We used some of the savings from our heat pump and applied it to other energy-saving features in the house and a higher efficiency unit. In the final analysis, we were able to build this house, make it more energy efficient, and do it at a lower cost.
A heat pump is an air conditioner which cools the house in summer like any air conditioner. But in winter, the heat pump runs backwards, taking heat from the outside air and putting it into the house. The terms tons and tonnage refer to the cooling capacity or size of an air conditioner or heat pump. 2 or 2.5 ton heat pumps may have been considered too small for homes built a few years ago, but many energy-efficient passive homes now require these small units. Bigger is not better. A very simple engineering calculation, and not guesswork, should be used to determine the correct size of the air conditioner or heat pump. Air conditioning contractor and mechanical engineer Jim Adams explains.
The proper method of sizing the HVAC equipment is to use a heat loss, heat gain form, such as this. A form such as this has a lot of numbers on it, but there's very few numbers really used in the calculations, and it's fairly simple once the size of the windows, doors, walls, and so forth is obtained. A 15-minute calculation of a heat loss, heat gain can result in hundreds of dollars of savings to the homeowner and years of comfort. If the equipment is oversized, run times will be shorter, resulting in higher operating costs, and during the summer, higher relative humidity conditions during the off-cycle. A properly sized system should result in better comfort conditions in the house, lower operating costs, and a longer-lived system.
Heat pump sizes should be different under different conditions. Take 2 identical houses. If the only difference between the 2 houses is different orientations to the sun or the use of tint glass in one, heat pump size requirements can differ as much as 1 full ton. Computers make the job of calculating the air conditioner size much easier. Only a few minutes are needed to calculate the correct size, taking into consideration the special conditions for your home. These few minutes can result in great savings for you, instead of wasting money on an unnecessarily large heat pump or air conditioner. Ask your air conditioning contractor for a copy of this calculation. Remember that efficiency does not mean the same as size or tonnage. Size is determined by a Manual J calculation, but The homeowner can choose the efficiency from available models of the correct size. A higher efficiency heat pump costs less to run while providing the same amount of cooling. When choosing the efficiency, look for the SEER and the COP. The term SEER, Seasonal Energy Efficiency Ratio, describes air conditioner efficiency. The larger the SEER, the greater the efficiency. SEERs range from 6 to 15. The term COP, Coefficient of Performance, describes heating efficiency. Like the SEER, the larger the COP, the greater the efficiency. COPs range from 2 to 4. For this climate area, a heat pump with an SEER between 9.5 and 10.5 and a COP between 2.9 and 3.1 is recommended for homes that are conditioned 24 hours a day. Surprisingly, as much as 50% of the efficiency of a heat pump can be lost if it is charged with the wrong amount of refrigerant. Charging procedures and pressure charts from the manufacturer must be used. If the wrong amount of refrigerant is used, not only can the efficiency drop, but the tonnage can drop and the heat pump will wear out sooner, perhaps even years sooner. If natural gas is available in your area, a natural gas furnace with electronic ignition is a good investment, equivalent to an investment in a heat pump. Homeowners should consider two types of energy-saving thermostats. One type, called an outdoor thermostat, is used in addition to the regular thermostat. It cuts heating costs by reducing the amount of resistance heat used with a heat pump. Resistance heat, like the glowing coils inside a space heater, helps the heat pump raise the indoor temperature quickly, but resistance heat costs up to 3 times as much as the heat pump's main heating system. One way to save heating dollars is to use an outdoor thermostat to prevent the resistance heat from coming on except when it is needed at outdoor temperatures below 45 degrees. The second type of energy-saving thermostat is the setback or programmable thermostat. Controlled by a computer chip, it saves energy by following a homeowner's instructions to operate the heat pump at a less comfortable temperature while people are away from home. Programmable thermostats provide convenience by bringing the house to a comfortable temperature at a pre-selected time. However, the same savings can be obtained by manually readjusting a regular thermostat, but the homeowner must return to the home, readjust the thermostat, then wait until the temperature reaches a comfortable level. Another way of reducing cooling costs is to use fans, ceiling fans, wall fans, or table fans. With moving air, people feel about 5 degrees cooler. This allows the air conditioning thermostat to be set at a higher and more energy-saving temperature. Fans cool by helping body water evaporate from the surface of the skin, causing a chill effect. Fans do not lower the temperature of the room, so using fans in unoccupied rooms always wastes energy. In winter, fans cause the same chill effect, so they do not help you feel warmer, nor do they save energy. Homes with several floors present special problems for air conditioning and heating because warm air always rises to the upper floors. VEARIL, an air conditioning system designer, explains.
In heating and air conditioning a 2-story house, you run into some unique problems. Hot air tends to rise. Therefore, in the summertime, your upstairs can be hot. In the wintertime, your downstairs can be cold. This is not a mechanical problem. This is a distribution problem. There are 2 basic solutions to this distribution problem. The first one is installing 2 oversized heat pumps in your house. The first oversized heat pump upstairs to take care of the cooling load in the summer. The second oversized heat pump downstairs to take care of the heating load in the winter. This solution is expensive because it costs more to buy the equipment, it costs more to operate the equipment, it costs more to maintain the equipment, and your house is not as comfortable because it does not control humidity as well as it ought to. The second solution is to install 1 properly sized heat pump in your house in addition to using motorized dampers. These dampers will control the air to where it's needed, upstairs in the summer, downstairs in the winter.
In nearly all cases, a two-zone motorized damper system with just one heat pump plus larger capacity duct costs less than a two heat pump system.
This is a 3,800 square foot, two-story house which received bids for up to 6 tons of cooling using 2 heat pump systems. By installing motorized dampers, we were able to install 1 4-ton heat pump. This particular house has 4 zones using thermostats in each zone for comfort. The customer has been very pleased with its operation and the equipment has performed excellent.
Even a low-cost splitter damper operated by hand can be used to avoid the cost of a 2 heat pump system. The homeowner must adjust the damper from season to season. Bob Sagan of OWENS-CORNING Corporation demonstrates the use of a splitter damper.
You can see that with the splitter damper in this position, the airflow comes up into this section of the house. With the splitter damper in this position, the airflow comes off the air handler into this section of the house.
Another opportunity for savings is through the design of the distribution or duct system. This is a typical distribution system. In the summer, air cooled in the air handler, shown in green, is supplied to the rooms through a supply duct, shown in blue. The cooled air passes through the rooms of the house and picks up the heat. All of this air is then returned to the air handler through the return duct, shown in red. A more efficient system uses free air return. A free air return system eliminates the need for the return duct in the attic. The rooms and hallways of the house actually serve as the return duct. To save more energy, the air handler should also be placed inside the house because air handlers leak expensive conditioned air. With less duct work, there is naturally a reduction in duct cost. In a typical system, an average of 20% of all the air sent into the duct leaks out into the attic where it provides no benefit. A reduction in the amount of duct reduces the wasteful leakage, resulting in lower heating and cooling bills. And the heat pump can be smaller at a savings of hundreds of dollars. Remember, the most cost-effective and energy-efficient location for the air handler is within the conditioned space. However, when the air handler is located inside, the pipe for the refrigerant lines needs to be sealed at the inside opening as well as at the outside opening to prevent air from leaking into the house. If the air handler cannot be located inside, the second best place is the garage, but keep a free air return. To create the free air return with the air handler in the garage, use a grill through the wall between the house and the garage. There are 2 drawbacks to this location. Remember, air handlers usually leak, so valuable conditioned air is lost into the garage. Also, the air handler support box leaks. The support box needs to be sealed and insulated. In Florida, the state energy code requires insulating to a minimum R value of 4.2, a requirement often overlooked. If the support box is not sealed and insulated, energy losses can be costly, enough to heat and cool a room all year long. 2 other less favorable locations for the air handler are in the crawl space under an off-grade floor, as well as the attic. In both locations, the equipment is difficult to service and maintain. In addition, in the attic, the water condensed by the cooling coil may leak and damage the ceiling. It is not difficult to put the return duct and the air handler inside the conditioned space, but the real problem is, how can you get the supply duct out of the attic and into the conditioned space? For a multi-story house, it's relatively easy and less costly. No supply duct is used in the attic. The second floor receives supply air from the floor vents, and nothing changes on the first floor. With this method, approximately half of the total duct can be eliminated. Although the remaining duct has to be larger, significant savings result from reduced labor. In addition, potential energy losses resulting from the conditioned air leaking into the attic are eliminated. Sometimes furniture will block the flow of air from the floor vents. If this is expected, use wall stacks. The wall stack made of metal duct is placed inside the wall, keeping all the duct inside the conditioned space. David Lingerfelt is an award-winning builder of energy-efficient homes.
In a two-story house like this one, it is relatively easy to put all the duct inside the conditioned space. You just put it in the space between the floors. But for a one-story house, it is a little more difficult to do this, even with a cathedral ceiling. I found a way to keep all the duct inside the conditioned space of a one-story house that I built.
The duct is hidden inside this soffit, which serves as a plant shelf. Other soffits and dropped ceilings in hallways hide the rest of the duct. All of the duct is below the insulated ceiling, so it's inside the conditioned space. None of it is in the attic, so there are no energy losses, no losses in the supply duct, no losses in the return duct. Homeowners face another choice when selecting the type of duct to be used. 3 types of duct are commonly used: round metal duct, fiberglass duct board, and flexible plastic duct. Round metal duct has several advantages. It is very smooth, so it minimizes air pressure loss and allows smaller diameter duct to be used. No mildew or fungus can grow inside the galvanized, zinc-coated surface, and if the joints are taped properly with the best quality foil tape, it can be made very airtight. One caution: it is very important to seal the seams and joints of the duct carefully during installation, because duct insulation will cover the tape and hide any leaks that may develop. Prefabricated fittings, which require little skill to install, are available. Fiberglass duct board is another type of system. If sealed correctly, it has very little air leakage. Segments of fiberglass duct board can be machine fabricated to help reduce labor cost, but of all 3 duct types, it requires the highest degree of skill to install. The third type of duct is flexible plastic duct, called flex duct. If great care is taken to overcome its tendency to leak at joints, it can be made fairly airtight. To comply with the energy code in Florida, flex duct should be sealed using a thick sealant, like this one called a mastic. Gaskets or tapes can be used instead of mastic, and soon superior tapes with acrylic adhesives will be available. In addition, all flex duct must be fastened to the fitting using a strap or clamp. While most homes today are well insulated with R30 in the ceilings and R16 in the walls, an area often overlooked is the insulation value of the duct. Consider the fact that all of the air-conditioned and heated air of a house flows through duct with an R value of only 4.2. Just think of the energy loss. Fortunately, it's fairly easy to add insulation to the duct. Higher insulation values are available for round metal duct and fiberglass duct board, and in some cases, insulation can be blown over these ducts. Landscaping completes a comprehensive plan for the passive home, and no other aspect of energy efficiency can be more varied or more beautiful than the finished landscaping. There are, however, some good basic principles to keep in mind when landscaping for energy conservation. Terry Del Valle, an extension agent, outlines some low-energy landscaping principles.
There are 3 groups of plant materials that could be used. Trees, of course, are one that we think of immediately. Another are vines and shrubs, and a third are ground covers. All of these help to promote energy conservation within the home. When we're thinking of shade from trees, we're thinking of shading the sidewalls versus the roof area. The east and west walls of the home will receive twice the amount of sun during the hot summer months as the north and south walls do.
Since the east and west sides of the house receive so much of the sun's heat, the landscaping should be designed to shield these sides, especially the windows, using shade trees, shrubs, or vines.
There are some other ideas to use landscaping to save energy. For example, shade the heat pump compressor unit. Eliminate the need for mowing and other kinds of yard maintenance by keeping as much natural area as possible, or by using low-maintenance ground covers instead of turf grass.
Landscaping for energy efficiency is a real bargain for most homeowners because landscaping is usually planned for aesthetics. But landscaping is only a small part of the energy efficiency picture. We've covered a vast range of energy-saving features in this series, some of which will require additional expenditures. Which ones should you include? That's something we'll have to decide based upon many factors such as cost effectiveness of each feature, the compatibility of each feature with your home design, lifestyle, and so on. But let me give you a summary of the energy-saving features we've covered, beginning with the ones that cost less than typical practice. Number 1, size the heating and cooling equipment. Insist that a manual J calculation be performed on your home, and get a copy for your files. Number 2, avoid using more than one heat pump, even in homes with more than one story. Number 3, use a free air return system. Remember to set aside a closet inside the house for the heat pump's air handler. For homes with more than one floor, locate as much duct as possible in the space between the floors. Number 4, use R30 blown-in insulation in attics whenever possible. It is less expensive than bats. Number 5, on walls, omit vapor barriers from the inside surface of the walls and paper facing from the bat insulation. Number 6, eliminate all horizontal or sloping glass such as skylights, since there are year-round energy wasters. These practices will reduce both construction costs and future energy bills. The second category of energy options are those which cost the same as conventional practice to include in the construction process, but will reduce energy bills. Number 1, choose a lot and a house plan combination that situates the smaller walls and fewer windows on the east and west. Number 2, place the garage on the east or west side to shield these sides of the house from the impact of the hot summer sun. Number 3, limit the total glass area to an amount equal to 10% of the floor area. Place half of this glass on the south. And don't forget to arrange the windows for cross ventilation. Number 4, choose a floor plan that keeps morning activity areas away from the east side of the house and afternoon areas away from the west side. Number 5, locate the attic access and laundry area outside the air-conditioned space. Number 6, use energy-saving framing techniques. Number 7, locate the heat pump's compressor unit in a shaded area. Number 8, make sure the heat pump is charged correctly using the manufacturer's charts for the particular model purchased. Number 9, use a low-flow shower head, one of the best energy-saving devices for reducing energy bills. Look for models that deliver 2 gallons per minute or less. The last category of energy-saving options are ones that cost more than the typical practice. So here's a priority list, beginning with the best investments. The top 3 investments are virtually tied, but we'll list them as follows. Number 1, use tint glass in all windows and doors that are not shaded. Remember to reduce the size of the heat pump when using tint glass. Number 2, seal the ductwork. Even in many new homes, the ductwork is not as airtight as it should be. Number 3, choose a more efficient heat pump. Number 4, use a foam board sheathing with an R value of about 4 on the walls. Number 5, airtighten your home. The off-grade floor, walls, and ceiling using care emphasized in this series. Number 6, buy a more efficient water heater, one with an energy factor near 0.95. Number 7, choose a refrigerator that consumes less energy. Remember that with some advanced planning, you can increase the energy efficiency without always increasing construction costs. And the benefits of an energy-efficient home are many. Lower monthly utility bills, increased comfort, and improved resale value. We hope you've enjoyed these programs on energy-efficient construction and that you'll be able to apply many of the ideas and techniques suggested. For more information, you may write to the address at the end of this program. And don't forget, you can contact your local utility. Make energy efficiency part of your building plans.